Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our first lesson on a given Form 2 mathematics topic called equations of a straight line. So we'll start by looking at what we call the gradient, or what we simply call the slope. So either the gradient or the slope of a straight line, the gradient or the slope of a straight line, the gradient or the slope of a straight line. So to understand what we mean by the slope or the gradient, we'll start by looking at this particular line that is on a Cartesian plane. So we have the two axes, that is the vertical axis, or what is called the y-axis. Then you also have the horizontal axis, also called the x-axis. Then I want us to consider a straight line running from that is the lower side of the x-axis towards the upper side of the y-axis. Now, if we consider this particular line, I want to let 2 points on this particular line. So we can have our point A here at this particular point here. So suppose this is our point A having the coordinates of x1, comma y1. This one simply means that the x coordinate here, of course, will be x1. Then, of course, the y coordinate here, it will be given by y1. Then I also let another point B on lie on the same line. So I'll let point B to have the coordinates of x2, then comma y2. So this one simply means that along point B on the x-axis, the coordinates is x2. Then, of course, along the y-axis, the coordinate of point B will be given by what we call y2. Now, notice that the distance between point y1 and y2, that one we call it the change in y. So this one is representing the change of values along the y-axis. Then, of course, from x1 to x2, this one will represent what we call the change in x, or the change of values along the x-axis. Therefore, if we want to find the gradient of this particular line, it will be given by the following equation. So we say that the gradient or the slope, so we say that the gradient of the line AB, or what we are calling the slope of line AB, of this particular line AB, it will be given by the following. So the slope or the gradient is given by the formula, the change of values along the y-axis, or what we simply call the change in y, the change of values in the y-axis, divided by the change of values in the x-axis, the change in x. So this one can be abbreviated as a change, can be denoted by this particular triangle. So when we talk of change, this one simply means that change in y divided by the change of values along the x-axis, which can be given by, when we look at the change of values along the y-axis, the change in y will be given by y2 minus y1. So this is y2, then of course minus y1, then divided by the change of values along the x-axis is x2 minus x1. So this is x2, then minus x1. So this is how we get the gradient or the slope of a given straight line, say AB. Then we move to the next concept of this particular topic, which is called the intercepts of a straight line. So we look at the intercepts of a straight line, the intercepts of a given straight line, Now, what do we mean by the word an intercept? So an intercept, so let's start by defining an intercept. So an intercept simply refers to a point. So an intercept is simply a point. It is defined as a point where a line, that is a straight line, a point where a straight line cuts, an axis. It cuts an axis. It can be either the x-axis or the vertical or the y-axis. To understand that, let's consider this particular line here. So suppose this is our vertical axis, then of course we have the horizontal axis, or what we call the x-axis here. So suppose this is my y-axis, then of course this is my x-axis. We are going to consider these two. Then we consider a straight line running from the y-axis towards the x-axis this way. Then if this particular line is cutting our vertical axis through the point, let's say, suppose this is point 3, then of course maybe this is 2, then of course we have 1 here. Then you also let suppose this point, maybe this is point 2, then of course this is point 1 along the horizontal axis. Then what we call the axis of this particular line, it will be given by the following. So this particular point here, we call it the so this point here, let me use a different ink. So the point 3 here, this is what we are calling the y-intercept. This is what we call the y-intercept. The y-intercept. So a point where the line cuts the y-axis, we call it the y-intercept. Then this point here, we call it the x-intercept. This is what we call the x-intercept. That is a point where the line cuts the x-axis. Therefore, let's look at a few definitions. Let me make a line here. So we'll start by defining what we call the x, or the, let's start with the x-intercept. So the x-intercept is a point, is simply a point where, refers to a point where the line, cuts, the x-axis, a point where the line cuts the x-axis. So that is what we call the x-intercept. So at this particular point where the line cuts the x-axis, this is what we are calling the x-intercept. For example, in this case, we can say the x-intercept of this particular line is was equal to 2. So the x-intercept in this particular case is equal to 2. Now, there is a point that you need to note here. So you need to note that at the x-intercept, the value of y will always be equal to 0, or the y coordinate will always be equal to 0. For example, if we were to state this particular point here, actually this point will be 2, 0. This point will be stated at 2, 0. So that the x coordinate is 2, whereas the y coordinate is 0. So at the x-intercept, the y coordinate will always be equal to 0. So that's a very vital or crucial point to note. Then the other thing we need to know is that is what we call the y-intercept. So the y-intercept, this one simply refers to a point. So this is a point where the line cuts, a point where the line cuts the y-axis, a point where the line cuts the y-axis, we call it the y-intercept. So it is also crucial to note that at the y-intercept, or at the point where the line cuts the y-axis, at the y-intercept, the x-coordinate will always be equal to 0. For example, if we consider the y-intercept, for this particular point will be 3. So we'll say the y-intercept is equals to 3. So because the line is cutting the y-axis at point 3. If we were to state this particular coordinate here, the coordinate will be 0, 3, meaning that the x-coordinate is 0, whereas the y-coordinate is 3. So at the y-intercept, the x-coordinate will always be equal to 0. So those are two very key points that you need to note. Then the third concept on this particular topic is what we call the equation of a straight line, or the general form of a straight line. So we just look at the equation. Look at the equation of a straight line. Equation of a straight line. The equation of a straight line. So we'll start by what we call the general form of the equation of a straight line, whereby we are saying that the general form of the equation of a straight line, the general form of the equation of a straight line, of a given straight line, will be given by the following. The general form of the equation of a straight line is given by, by this particular equation. So the general form is usually y is equals to mx, then of course plus c. Of course, we are going to define what we mean by each term. So where the y usually stands for the y coordinate, of any given point that is satisfying that particular line, then m usually represents the gradient of that particular line, also called the slope of a given line. Then the x usually represents the x coordinate, the x coordinate of any given point on that particular line. So this is the x coordinate. Then c usually represents what we call the y-intercept. This one represents the y-intercept. Remember, y-intercept is simply a point where the line cuts the y-axis. For example, let me sketch a certain line here so that we can use it to show the points that we are actually defining on this particular line. Now, suppose this is our Cartesian plane having the x-axis and of course the y-axis. So if we consider a straight line starting from this particular point here, then maybe moving in towards this particular direction here. So suppose this is maybe point 3 on this particular line, then maybe this is 2, then of course we have 1 here, then maybe this is point 4. So the y-intercept of this particular line will actually be point 3, because this is a point where the line is cutting the y-axis. Now suppose this is maybe point 5. I consider a certain point on this particular line passing through the point 5. So suppose this is the point 5, then we let this particular point to be corresponding maybe with a certain point 1. Then of course we have 2 here. So if this particular point, it will be given by, so this point will be labeled as 1, 5. We always start with the coordinate of the x coordinate, then of course we add the y coordinate. So such an equation could be represented by this particular equation of the line. So suppose this line is represented by the equation of y maybe is equals to 2x, then of course plus 3. Suppose this is the equation of this particular line here. Then if we compare with y is equals to mx, then of course plus c, this one simply means that we can clearly see that at the point 1, 5, at this particular point here, the x will be represented by 1, then of course the y will be represented by 5. Such that if you substitute these particular coordinates in the equation, then the equation should balance. For example, if this is if our y is actually positive 5, it means that we'll have 5 being equal to 2. Then of course into brackets our x coordinate is 1 for this particular point, then of course plus 3. So you can see that 5 will be equal to 2 times 1, you'll get 2 plus 3. Clearly you can see that 5 will be equivalent to 5. So you can see our equation is actually balancing. Therefore we can say that through the point 1, 5, the x coordinate will be 1, the y coordinate will actually be 5, then the gradient, which is m, which is equals to the gradient of this particular line. So the gradient will actually be given by a positive 2 because you can see m is actually corresponding with 2. Then our y-intercept, the y-intercept will be given by the value of c, which is actually positive 3. Clearly you can see that this is positive 3. And even from the straight line, you can see that the line is cutting the y-axis at 0.3. Therefore, our y-intercept is positive 3. Then, so having looked at the general form of the equation of a straight line, we can also look at other forms of the equation of a straight line. So we can say that the other forms of the equation of a straight line, the equation of a straight line are, so other forms are or include. So the first form that we are going to look at is the form called ax, then of course plus by, then plus c is equals to 0. Of course, where a, b, and c, are simply constants, where a, b, and c are constants. They are simply constant values. So the same format can also be rewritten this way. We can also talk of ax, then of course plus by is equals to either negative c or simply positive c. Remember, c is a constant, therefore it can be either a positive value or a negative value. Of course, also where a, b, and c, a, b, and c are constants. A, b, and c are constants. For example, let's consider the equation that we had. The previous equation that we had was y. The equation that we were considering was actually y is equals to 2x plus 3. So if I use the same equation, so if we consider y is equals to 2x plus 3, we can change this particular equation in either this format or the second format. For us to achieve that, for example, to change in the form ax plus by plus c is equals to 0, we are going to take these particular values to the left-hand side of the equation, such that we are going to have negative 2x, then of course plus y, then minus 3 is equals to 0. I've just taken these particular values to the left-hand side, such that it is in the form ax, then of course plus by, then plus c is equals to 0. So remember, this one can be written as negative 2x, then of course plus 1 y, then of course minus 3, then this one is equal to 0. Such that when you compare the values directly, you can see that the value of a will be given by negative 2, the value of b will be given by positive 1, then of course the value of c will be given by negative 3. So clearly we can see that the value of a will be negative 2, then the value of b will be positive 1, then the value of c will be given by negative 3. The same equation can also be rewritten in this particular second format. Remember, our second format was ax. It was ax plus by is equals to c. So this equation will be, so I'll simply take this particular value towards the left-hand side, so that I'll have y, then of course minus 2x being equal to positive 3, which can be rewritten as negative 2x, then of course plus 1y is equals to 3. So it is exactly in the form ax, then of course plus by is equals to c. Clearly, the values of a, b, and c will be given by the value of a will be negative 2, the value of b will be positive 1, then the value of c will be positive 3. Therefore, for this case, a is equals to negative 2, b is equals to positive 1, then c is equals to positive 3. So those are the other forms. Then we look at the second format of the other form of the equation of a straight line which can be taken. So the other form will include the following. So the other form, which I'm calling it Roman 2, the equation of a straight line can also be given in the form x over a, then of course plus y over b being equal to 1. So this one we also call it the double intercept form, the double intercept form. Suppose we have an equation in the form maybe 9x, then of course plus maybe 3y, maybe minus 18 is equals to 0. We can change it in this particular form. So of course in this particular form we are also saying that the value of a must not be equal to 0, where a is not equal to 0, and of course b is also not equal to 0, because if these two values are equal to 0, then these particular fractions will not be defined. So the equation is only defined if the values of a and b are not equivalent to 0. So to change to this particular format, I'm going to rewrite this as 9x then plus 3y is equals to positive 18. Then I'll divide through by 18 so that I retain 1 on this other side. So I'm going to divide through by 18, divide through by 18, divide through by 18, so that I'm going to end up with the following. So 9 into 9, 1, 9 into 18, that is 2 times, 3 here, 1, 3 into 18, this is actually 6 times, then of course 18, 1, 18, 1. So we remain with a half x, then of course plus 1 over 6y being equal to 1 over 1, which is just 1, which can be rewritten as, so we can write this equation this way. So we are going to have the following. So this can be written as x over 2, because 1 times x you get x, then of course plus 1 times 1 that times y you'll get y, then of course over 6 being equal to 1. So this is exactly in the desired form, which is x over a, then of course plus y over b being equal to 1. So clearly you can see that the value of a will be given by 2. So clearly a is corresponding to 2. Then the value of b will be corresponding to 6. So we can say that the value of a will be given by 2. Then of course the value of b will be equivalent to 6. So in the next lesson we'll be continuing with the introduction of this topic. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.